Okay, let's start going through this. So now if you notice, every single problem in this do now is some number squared. Does that mean when you have that some number squared, that little exponent of 2, does that mean that number times 2? So is 1 squared 1 times 2? No, what's 1 squared? 1 times 1, right? It's that number times itself. So here, 5 squared is not 10, right? 5 squared is 5 times 5, which is 25. What if it wasn't a squared? What if it wasn't a 2? What if it was 5 to the third power, to the power of 3? Would that be 15, 5 to the third power? No, if it was 5 to the third power, it'd be 5 times 5 times 5. And then you'd multiply 5 times 5 is 25. And then 25 times 5 is 125. So whatever that exponent is, it tells you how many times you're multiplying a number times itself. Not adding that number plus itself, it's timesing it by itself. So 1 to the second power is pretty easy because 1 times 1 raised to any power will always be 1 because 1 times 1 is 1. So now we're just going to go across. 2 to the second power is what? 4, yeah. Let's just go. Noah, what's 3 to the second power? 9. Stella, what's 4 to the second power? 16. Sebastian, what's 5 to the second power? 25. Maya, what's 6 to the second power? Good. Bella, what's 7 to the second power? Seven to the second power. That's okay. What's 7 times 5? Good. 7 times 5 is 35. So then 7 times 6, we're going to add 7 more, which is going to bring us to 42. And then 7 times 7, we're going to add 7 more, which brings us to 49. Perfect. Kate, what's 8 squared? 64. You got it. Luciana, 9 squared? 81. Jack, 10 squared? Okay, so what I would hope, we're not done, but I'm going to stop here. What I would hope is that all of you would have, at least at this point, from 1 to 10 squared memorized. Meaning if I say 4 squared real quick, Maya's gonna be like 16, bam. If I say 9 squared real quick, Sebastian's gonna be like 81. I want you guys to have that almost like lightning. But now it gets a little bit bigger because we haven't really, you probably haven't used the rest of these very often in like pre-algebra, numbers bigger than 10 squared. But for geometry, it would help also knowing these like lightning. So we're going to go to 11 squared. Now, let's say for now you don't know what 11 squared is. All you would do is say 11 times 11 and you would multiply. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 again is 1. Put a 0 as a placeholder. 1 times 1 is 1. 1 times 1 is 1. Add, and we get 121. Now, I don't want you every time it's 11 squared to do 11 times 11. I want you to be like lightning bam, just like when I say 3 times 3 and you're like 9. I want you to be like 11 times 11, 121. I want you to have these memorized. Make index cards, keep writing them down. Whatever it is, it will help you. All right, I'll keep going. 12 squared, 144. Again, if you don't know it, could you just do 12 times 12? Absolutely. I'd rather you do 12 times 12 than get it wrong. But I want it to be like it's 4 squared. Just like 4 squared is 16, I want you to know 12 squared is 144. All right, going a little bit deeper. 13 squared is going to be 169. 14 squared, all you're going to do is change the 6 and the 9. So if you could memorize that 13 squared is 169, then you could remember that 14 squared is 196. We're just switching the 6 and the 9. 15 squared is 225. Sixteen squared is 256. 17 squared is 289. 18 squared is 324. I'm going to say I'm guilty. I actually don't know 19 squared like BAM. It doesn't come up that often, the 19 squared, but we should still know it. This is 361. So guilty. I didn't really know. I had to hesitate for that 19 squared. And the 20 squared is 400. So I would really, really like for you to have all of these memorized from 1 to 20. And for the most part, you should probably have half of these already memorized. So from 1 to 10 squared, for the most part, for most of them, you should have them memorized. So it's only 10 more. Okay. I'm going to sidetrack for a minute. You guys don't have to write this down. But this symbol right here, that's actually not division. This is a square root. And what this square root is saying, it is asking us what number times itself gives us that number inside that square root. Inside, it's a square root is sometimes called a radical, and the number inside the radical is called the radicator. So this little symbol actually is a question asking us, what number times itself gives us 25? So you guys tell me, what number times itself gives us 25? But isn't it also -5? Doesn't -5 times -5 also give us a positive 25? So we're going to get to a point where we're solving for x. And when we're solving for x, we have to account for the -5 and the +5. But if we're just simplifying the radical, they only ever want the positive value. So if we're just simplifying, we're not solving for x. We just want the positive value. So here, let's see what these directions say. The directions don't say anything. The directions should say simplify. And even more so, is there an x to even solve for in the problem? It's not an equation. It's not saying solve this equation. It's just giving us a square root, which implies we have to simplify. So when we're simplifying, we only account for the positive version. So what this is saying is what number times itself gives me 100? And you tell me what number times itself gives me 100? 10. Do you guys see now why it's important to have all of these memorized? All right, no more radical. The radical is the question. That square root is the question. It's saying what number times itself gives me 100. Our answer isn't what number times itself gives me 10. That radical is just a question. So our answer is the whole number 10. All right, what number times itself gives us 49? 7. All right, I want you guys to do 3 and 4 by yourself and then just zoom in so I can see and just turn it over to show me. So you're doing 3 and 4 by yourself. Perfect. Perfect, perfect. I love that I'm not seeing any radicals. Perfect. Perfect. I love that these answers do not have radicals in them. Perfect, perfect. All right, perfect. So it's saying what number times itself gives me 16? It's 4. What number times itself gives me 196? It's 14. Okay, so now it's saying what number times itself gives me 27? And I'm like, wait, what's going on here? I go back up just to double check. I see that 5 times 5 is 25, but then 6 times 6 is 36. There's no 27 there. Right, that's okay. This means that 27 is not a perfect square. Where these other numbers, see all 20 of these numbers, 1 to 400, those are considered perfect squares. What a perfect square is that it's the answer of a number times itself. So, 4 is a perfect square because 2 times 2 is 4. 36 is a perfect square because 6 times 6 is 36. So a perfect square is the product of a number times itself. This just tells us that 27 is not a perfect square. So the square root of 27, what number times itself gives me 27, will not be just one whole number by itself. So what are you going to do in these scenarios where it's not just a whole number? What we're going to do is we're going to break it into factors. And when we break it into factors, we're looking not for just to make a prime factor tree. We're looking for pairs, two of the same number. So when I think 27, the first thing I think of is 3 times 9. This is where third grade is going to help us, guys, with our multiplication facts. So we're going to say 3 times 9. I don't have a pair, so we keep looking for pairs. Then I'm going to break down. I can't break down the 3, so I'm going to break down the 9. What's 9? 3 times 3. So now I'm going to circle a pair. We're looking for twins. We don't want triplets. We're not circling that last 3. We just want a pair of twins. Now what you're going to do is whatever number you circled, what number did we circle? 3. We circled a pair of 3s. You're going to put only one of those 3s on the outside. So whatever you circle, you put on the outside one time. Then you're going to look, whatever's not crossed out and not circled is going to go on the inside. Well, doesn't that mean there's one 3 that's not crossed out and not circled? That 3 is going to go on the inside. So what this tells us, and we can't check it now because I didn't teach you about multiplication with radicals yet, but what this tells you is that 3 root 3, that's how you would read this, 3 root 3 times 3 root 3 would give me 27. So what number times itself gives me 27? 3 root 3 times 3 root 3 gives us a whole number 27. All right, let's keep going. So now we want 24. We want to simplify the square root of 24. So again, I'm thinking, well, 5 times 5 is 25. That means 24 is not a perfect square. So we're going to break this down. It doesn't matter what factors you start off choosing. So you tell me, what numbers multiply to 24? Jack? 6 and 4 are actually the perfect answers. So we're going to go with 6 and 4. You could have done 3 and 8. You could have done 2 and 12. It doesn't matter. But I'm going to go with 6 and 4. Then we're going to break down that 4 into 2 and 2. Do we agree that 2 is a pair? So I can circle it. Okay, then I realize I can break down the 6 as well. So I'm going to break down the 6 and I get a 3 and a 2. But then I realized, oh, actually, I didn't really need to break down that 6. Why did I not need to break down that 6 if I had some foresight to this? It's not giving me what? 2 of the same number. Remember, our whole point in breaking this down is to keep looking for 2 of the same number. So you keep breaking it down if you're going to keep getting 2 of the same number. So if you don't know if you're going to get 2 of the same number, you keep breaking it down. But if I said, oh, well, I know 6 is just 3 and 2, that's not going to give me another pair. I can just leave it. But let's say we broke it down. We circled one pair of 2s. So that means 1, 2 is going on the outside. Anything else going on the outside? No, only what we circle goes on the outside. So 1, 2 is going on the outside. And now it looks like I have 2 numbers that are neither circled or crossed out. I have a 3 and I have a 2. Guess what operation I'm going to do with those? Any guesses? I have a 3 and I have a 2. You're going to multiply them. 3 times 2 is what number? 6. And that goes on the inside. So what does this tell me? 2 root 6. He said 2 root 6 times 2 root 6 is 24. That's what this is saying. Okay, 34. Do we agree 34 is an even number? Since 34 is an even number, what number has to divide evenly to 34 since it's an even number? Anybody know? 2. So if you didn't know this, you're going to just say 34 divided by 2. 2 goes into 3 one time. 1 times 2 is 2. Subtract. 2 goes into 14 7 times. So that's going to break 34 into 2 times 17. Am I able to break it down any more, this 2 or the 17? No, they're both prime. So that means root 34 is simplified. There's no number times itself that gives us root 34. It's as simplified as it gets. Can't do anything about this. Okay, I want you guys, actually, is this one going to be? Let's do this together. Let's do number 8 together. Okay, square root of 32. What number are you guys thinking for 32? Anybody? Jonah? 8 and 4, great choices. Let's go with 4 and 8. So now I'm going to break down that 4 into 2 times 2. And I'm going to break down that 8 into 4 and 2. So I circled one pair of 2s because remember, we're looking for pairs. So when I broke down the 4, I got 2 and 2, I circled it. I broke down the 8 because I believe I could get another pair. Do I have another pair just yet when I break down that 8? No, but what can I still do? Break down the 4. So let's go ahead and break down the 4 again and get another 2 and 2. There's another pair. Is everybody okay with how I've broken down and circled my numbers? Anybody confused with why that looks the way it looks? Okay, so now remember, whatever number we circle goes on the outside. So didn't I circle one pair of 2s? So I got 1, 2 on the outside. But then didn't I circle another pair of 2s? So guess what? Another 2 goes on the outside with multiplication between them. What number is left on the inside? What number is left on the inside? The only number that's not crossed out and not circled. Jack? 2. So 2 goes on the inside. So what does this give me? 2 times 2 on the outside, which is a 4 root 2. What does this mean? 4 root 2 times 4 root 2 gives me whole number 32. Do you guys want me to give you some divisibility tricks to know when a number is divisible by something? Let's go all the way to your bottom of your Cami and add a page. I'm just gonna... Okay, we ready? I'm going to tell you divisibility tricks. Okay, so the first divisibility trick, which I think everybody knows, if it is an even number. And what do I mean by even? What is an even number? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right? Aren't those all even numbers? So if it's an even number, it is, you can divide by 2. Okay, we know the first 3 I'm writing, I think you probably already know. The second rule for divisibility, another one, if it ends in a 0, the number can be divided by what? Anybody know? If the number ends in a 0, it can be divided by 10. Very good. So what do I mean if it ends in a 0? 10, 20, 30, 40, 50, 60, 70, 80, 90. Would 1,250 be divisible by 10? 1,250. Yeah. How do I know? 1250, 1,250. This is divisible by 10. How do I know this? Because it ends in a 0. That's how I know. Okay, so if it ends in a 0, the number can be divided by 10. The third one, I also think you guys know this. If it ends in a 0 or a 5, the number can be divided by 5. If it ends in a 0 or a 5, the number can be divided by 5. So what does this mean? Any number that ends in a 0 or 5. So like 55 could be divided by 5. 95 could be divided by 5. 1005 can be divided by 5. 70 could be divided by 5. 1350 could be divided by 5. So if the last number is a 0 or a 5, it can be divided by 5. How many people already knew those 3 rules? Great. I love that. All right. I'm going to tell you a few more rules that you might not know. Does anybody know the rule if it's divisible by 3, meaning 3 could divide into it evenly? Does anybody know that rule? Okay, this rule's a little bit different. We ready for it? If you add all the digits in the number and that sum is a multiple of 3, then the number can be divided by 3. Hey, can I give you guys an example? I'll let you write that down and then I'll give you an example. Let me know when you're done. Okay, an example would be 123. So what I'm saying is add all the digits. What does that mean? Add the digits. So I'm adding 1 plus 2 plus 3. All right, 1 plus 2 is 3. 3 plus 3 is 6. All right, is 6 a multiple of 3? Yes, since 6 is a multiple of 3, that means we can divide 123 by 3 evenly. And just to show you, 123 divided by 3. 3 doesn't go into 1, but 3 goes into 12 4 times. 4 times 3 is 12. Subtract 13. Bring down the 3. 3 goes into 3 one time. So 3 times 41 is 123. So that's the rule for 3. Okay, one more rule. And that rule is for 6, divisible by 6. We ready? So what is that? D, E. If the number is divisible by 2 and 3, then it will be divisible by 6. And those are the last two you may not have known of. And so this might help you try to find factors when we're doing these factor trees. So let's go back up. Is anybody still copying this last rule, divisible by 6? We ready? Okay. So let's go back up. All right, so now we're going to the 150. So you tell me, 150, what number are you thinking for this factor tree? What number are we thinking for this factor tree? Anybody? 10, exactly. Because it ends in a 0, isn't it divisible by 10? So 10 times, and really all you have to do is look at the numbers before that last 0, and that's what multiplies with the 10. So this is going to be 10 times 15. Any pairs right now? No, but can I keep breaking things down? Yeah. So then I'm going to break down the 10. What multiplies to 10? 2 and 5, right? And then I'm going to break down the 15. What multiplies to 15? Good. 5 and 3. Now, I see a pair of 5s. It is okay that they're coming from different branches. I can still circle them. So it's absolutely okay that they're coming from different branches. Now, whatever I circle is going on the outside. How many 5s am I writing on the outside? Just 1. So I'm going to write 1 5 on the outside, and there's 2 numbers left on the inside, a 2 and a 3. What do I do with those before I put it in the inside? Multiply them. So this is 5 root 6. All right, you guys do 10 by yourself. Actually, I'm sorry, I want to do 10 with you. There was something I want to show you. So for 500, I know it ends in a 0. So what would work for it? 10 and 50, right? But is there a better number than 10, a bigger number than 10 that goes into 500? Because it ends in 2 zeros, guess what goes into it? 100. Because it ends in 2 zeros, that means 100 goes into it. And guess what? 100 times what gives me 500? 100 times 5. Doesn't that make sense? Now I can break down that 100, and I can break down into 10 times 10. I know I can break down the 10, but I'm not going to break down the 10. Does anybody know why I'm choosing not to break down the 10? Caitlin? Good, because we already have a pair. And remember, our job is not to go down to primes. Our job is to look for pairs. So the minute we see a pair, we got to circle it. All right, now that I circled my pair of 10s, is there any other number to break down that I can potentially? No, 5 is prime. So I'm getting 110 on the outside and 1 5 on the inside. So that's 10 root 5. Okay, I'm going to have you do independent numbers 11 through 14 all by yourself. Oh, sorry, 11 through 16 all by yourself. And then I'm actually going to call it a day after that. The rest of this packet will finish next class. Oh, wait, there's no adding or subtracting in here. Sorry, we're not going to call it a day. I'm going to show you that last part. I thought there was adding and subtracting in here. Sorry, but the last part is not any different, really. Yeah. So actually, I'm going to jump around. I'm going to have you guys do 11, 12. Yeah, just 11, 12, 13, 14. I'd be happy with those. 11, 12, 13, 14. You don't have to do 15 or 16, and then we'll move on. All right, let's go through this. So 81. Well, 81 is a perfect square. Isn't that 9 times 9? So there's your pair. So 1 9 is coming out. Is there anything left on the inside? Nothing. So there's no radical, just whole number 9. How many people got that correct? Perfect. Now 28 is not a perfect square. So I'm going to break down into 7 and 4. 4 becomes 2 and 2, and now I can't simplify the 7. So this becomes 2 root 7. All right, 65, since it ends in a 5, that means it's divisible by 5. So I don't know this off the top of my head, so I'm going to go do my long division. 5 goes into 6 one time. 1 times 5 is 5. Subtract, bring down the 5. 5 goes into 15 3 times. So this gives me 5 times 13. Am I able to break down the 5 or the 13? No. So what does this tell us? There is no number times itself that gives me root 65. All right, 225. Well, 225, I hope you recognize as a perfect square. 15 times 15 is 225. So that's just 15. All right, so now the last thing I want to show you is now I'm putting a number in the front of the radical. Think back to pre-algebra. If I have a 3x, does anybody know what operation that represents when you have a 3 and an x, what that really means? Is that 3 plus x? Is that 3 divided by x? Is that 3 minus x? What's 3x? 3 times x. So when you have a number and then a variable, that represents multiplication. Same thing with a radical. When you have a number and then a radical, it represents multiplication. So this is saying -3 times the square root of 44. That's what this says, -3 times the square root of 44. But the way we read this is -3 root 44. That's how we would say, just like we'd say 3x, we don't say 3 times x. We would say -3 root 44. So now what we want to do is we want to break down this 44. Because it's an even number, what number goes into it? 2. So if I divide by 2, I'm going to get 2 and 22. And then again, 22 is an even number, so what goes into it again? 2. So that's 2 and 11. Is it okay for me to circle from different branches? Absolutely. So now I'm going to bring that 2 on the outside, but guess what numbers are ready? Well, don't guess. Look, what numbers are ready on the outside? A -3. So what we have here, it's going to be a -3 times 2, and then the square root of 11. And then -3 times 2 is a -6 root 11. And that's our answer. Okay, so I'm going to have you do 2 more problems. I'm going to have you do 18 and 19 on your own, and then we will call it a day. So you're doing 18, 19 on your own, and then we are calling it a day. All right, number 18. What should we have done? We should have broken down that 72. What numbers did you guys choose for 72? 8 and 9 is great. If you know your multiplication facts, it really makes things helpful. So then I'm going to break down that 9 into 3 and 3. There's a pair right there. I'm going to break down that 8 into 4 and 2. Then I'm going to break down that 4 into 2 and 2. Let's say you didn't choose 8 and 9. Let's say you chose 2 and 36. Would it still have worked out the same? Absolutely. It just would have taken you down a different path, but you'd still end up with the same answer. So now there's a 2 going on the outside and there's a 3 going on the outside, but we can't forget what's already on the outside. A 6. So this becomes 6 times 2 times 3. And what's the only number left over? A 2. So that goes back on the inside. So then we multiply the outside. 6 times 2 is 12. 12 times 3 is 36. So this is a 36 root 2. So what did I, 17, 18, 19? All right, so 19. I hope that you remember 121 is a perfect square. What times itself gives us 121? 11. 11 times 11, that's a pair. I already have a -5 on the outside, so I'm going to multiply that with 11. Is there anything left over on the inside? No, so that's just a -55. And this is where we finish.